Hello and welcome to PixElement. In this video I will be showing you how to start a project with LiDAR and imagery data. To start a LiDAR plus imagery project, select the option when prompted in the first step of the project creation process. You will then be prompted to upload your datasets, so drag and drop or browse for your images and import them. They will then come up on the map and you can see the footprints of where each photo was taken. The dataset that we're working with today does not have GCPs present, so we will click to pause processing to add some Tiepoints later on. We will then be prompted to upload our LiDAR file, which may be a LAS or LAS file. We will then need to choose our coordinate system. Since LiDAR has its own coordinates within the file, we can use the embedded system. If not, we can choose the appropriate system. We will then select our output coordinate system, which it has identified as being Pennsylvania South. Just like with the solo imagery project, we then have the ability to name our project, select if we want support, and what email notifications we would like, as well as what deliverables we would like for the program to render. When we are ready, we can confirm our overview and begin the processing. Once your project is uploaded, you will be taken to the registration tab where you will be able to add GCPs if you have them, as well as add checkpoints and tiepoints. In the LiDAR menu, you can toggle the photos taken, change the LiDAR point size and the point pick or snap radius if you want to be more precise. You're also able to switch views to color, intensity, and elevation. Since we do not have any GCPs available with this dataset, we are going to make some tiepoints, which you can add to the reference point library by hitting the plus button and selecting the photos you would like to reference. If you have a new file you would like to import, or if you would like to put in the points manually, you can hit the second plus button. For a LiDAR plus imagery project, you will need to add either GCPs or manual tiepoints within your project to align the photos with the LiDAR data. It is very important that in able to align the point cloud with LiDAR data, you will need to match the point in the photo with the point cloud to create a complete and accurate model. Typically, you would use GCP targets to align the LiDAR and photos together, but if you do not have them, you need to choose points both recognizable in the photos and the LiDAR point cloud. So we will choose the Pick Point tool to add to the LiDAR point cloud, and before picking our point, we need to make sure that the toggle LiDAR point is on, as well as that our point is a tiepoint in the reference point manager list. We can then choose our point in the LiDAR point cloud, and once we do that, we want to make sure that the point is placed correctly on the surface of the model, not above, up in the air, or down below. So make sure that you move around your model to correct for this. You can also click and drag the point around so it is placed correctly. Once it is correctly placed, you can move on to the reference point manager, where PixElement has identified the photos from your imagery dataset, where you can identify the same point in the photos and then register your data for final processing. It is important to note that when you register the LiDAR data with the photos, it is much easier to pick your points in the LiDAR cloud while using the intensity or elevation heat map versus using the RGB data. LiDAR data lacks color information, only having intensity values. Many drone LiDAR platforms add color by integrating a camera and performing a bore sight alignment with the LiDAR sensor. This often results in colorized point clouds that are geometrically incorrect due to alignment and calibration errors. Not only is the intensity point cloud easier to see and distinguish certain points, but it is inherently more accurate when working with LiDAR data. PixElement's integration corrects these RGB errors, producing accurate RGB LiDAR files. By registering LiDAR and GCPs in PixElement, the system adjusts for misalignment to improve model accuracy. So now we have some tiepoints down, and we can continue to process the project. If you do not have any GCPs, it is important to at least have some tiepoints and checkpoints. Checkpoints do not help improve the mapping solution. They are more like validation points to determine accuracy, not actually adjust the data. The tiepoints, however, help improve the mapping solution, and you can use any landmark that is consistent and in the same spot throughout the dataset. Upon completion, you can view your LiDAR dataset just like the original imagery photogrammetry option along with all of the deliverables. You will receive an email once each deliverable is done processing. You are also able to see the bundle adjustment report immediately and can view how well your drone coverage was for your project. Please see our tutorials playlist for more videos on how to use PixElement.